Hey everyone, and welcome back. This is going to be just a review video for solving quadratics. I'm going to go through the 5 different ways of solving quadratics. I'll have an example, I'll give a couple for you guys to do, and then I'll go through and show you how to solve them as well. So use this video to help you with figuring out the missing parts in terms of your knowledge and what you need to know moving forward. So the 5 types of ways of solving, we're going to review those, and then essential questions: when should I use which method? So, when should I pull out quadratic formula versus when should I solve by factoring? If you're told to use a specific method, then it's a little bit more obvious, but if you're not given a particular method to use, and you have a choice, well, which one would you do? And then finally, can I do it using the 5 methods? So, if you can't do it, you got to go back, watch again, or maybe check out YouTube. If you type in solve quadratics by and then insert method, there are tons of videos made by a bunch of different people about how to solve quadratics using different methods. Find one that speaks to you, that you understand, that resonates with you, and go with that and try and see can you apply the knowledge to the current problem you're facing. So our methods: solving by graphing, solving by factoring, taking square roots, completing the square, and then taking square roots, and then quadratic formula. So those are the 5 we are going to review today. Just a quick recap: when you're talking about solving quadratics, there are 3 scenarios. One is where there are 2 solutions, so the number we are trying to solve hits the parabola in 2 places. So if we're talking about solving when x is 0, we're saying that the quadratic is going to touch the x-axis in 2 different places. At one solution, the x-axis is tangent to the parabola at the vertex. So, at the vertex, there will be 1 point of contact. And then no solution is when the parabola does not touch the x-axis. Now, we do have to remember there's no real solution here, but there is going to be what we call imaginary solutions, and that will come up in following videos. So get out of the habit of saying no solution. Either say no real solution or 2 imaginary solutions. Okay, the first method of solving is solving by graphing, and we're going to use the function x squared plus 3x minus 10. The steps for using your graphing calculator are on the screen. I'm going to take you through those. So first up, you hit y equals. So your graphing calculator should look something like this. This is a TI-84. You may have a TI-83 or 85 or 86. They all pretty much have the same steps, though they may look a little bit different on the surface. If you are using Desmos, I will get to that in a second. So you type your function into the y1 spot. So y1 is going to be where y replaces f of x. And then you have x buttons on your calculator. You can see it on the 2nd column, 3rd button down. Type in your function, hit graph. So that is the button on the top right. And you should see your parabola appearing on screen. If you cannot see it, you may have to go to Window and adjust the window size until you can see it. So you would select what the x min, the x max is. So that is the width of the window. So from what x value to what x value. And then same thing with the y min and y max. What height do you want to be able to see? And then when you are looking to find the zeros, you hit second function and graph. So that opens up a table of values. And you can then see, okay, what are my coordinates? And that's one way of plotting it out. So this is what the table would look like. So pick your coordinates, plot it out, and then you would, if you have to solve by graphing, you would plot a horizontal line for the y value you're looking for and see where they meet, or you can use the table and you can see when is the y1 value equal to the y value I'm trying to find. If you're on Desmos and you plot the function in Desmos, it automatically pulls up some of the key points for you. You can see those in gray. So the 2 x-intercepts are already highlighted, the y-intercept is highlighted, and the vertex is highlighted. So key points in most graphs. If you are solving for a different y value, you would type in y equals blank in a second line, and wherever that intersects with the original parabola is going to be your solution. So you're going to solve each of these using a graphing calculator. Try and use both. So if you have a graphing calculator, TI graphing calculator, please try and use that. Go through the steps just so that you are prepared for going up to pre-calc stats and so on using that calculator. Check your work with Desmos though. See, what should I be getting? And if you get no real solutions, please write imaginary solutions, and we will dig more into that very soon. So pause the video, come back and check your answers. All right, welcome back. I'm just going to flash up the answers here because it is just a case of typing your calculator and following the steps. So I'm not going to do a live video of that because that would just take up extra time. First one, you should have gotten an x value of 1.472 and negative 7.472. Number 2 had no real solutions, so we said there are imaginary solutions here. And then the last one, 2.766 or negative 1.266. If you did not get those solutions, check your work again, double check it in Desmos, see if you can figure out the error. If not, let me know during one of our live classes. Next up is solving by factoring, and we did a lot of this in Algebra 1, so this should be the method along with graphing and quadratic formula that you're like, okay, I'm most familiar with these because I was asked to do this a lot. So when it comes to solving by factoring, there's a couple of steps that we need to remember. First up, you need one side of the equation to equal 0. So you're going to get all terms to one side of the equation. So in my case, that 10 needs to go. So we would subtract 10 from both sides. So on the right side, I'll be left with 0. So I'll have 2x squared minus 2x minus 40 is equal to 0. If there is an a value, so that is a lead coefficient, so you can see up in my formula up here where a, b, and c are when I refer to a, b, and c. If the a value is greater than 1, you're going to divide by that a value. So everything, I'm going to divide by 2 and factor it out. So that just means I'm placing it over here, and then what's left is going to go inside my parenthesis. And that should not be 2x. So we would have 1x and then 20. So if I distribute the 2 back in, I will get back to my original equation and still equal to 0. Now at this point, we are asking ourselves, what are factors of the c value, so that is now negative 20, that add up to be negative 1. So factors, remember, are numbers that multiply to give that desired value. So what numbers multiply to be minus 20? You've got 1 and negative 20, 2 and negative 10, 3 doesn't go in, 4 does, 4 and negative 5, so then we're up to 5 and negative 4, 10 and negative 2, and 20 and negative 1. So when you take those two factors and add them together, first one I get negative 19, then negative 8, negative 1, positive 1, 8, and 19. I'm looking for the pair of factors that when you add them together, you get negative 1. So that is my 4 and negative 5. So then the 2 is still there, but inside the parenthesis, we open up two linear factors. So we're going to have two linear factors that are multiplied, two linear binomials. First one is going to get that first factor, positive 4. Second one is going to get that negative 5, and this is still equal to 0. So if I were to distribute all this, I would get back to my original equation. Some things I can tell here. We want to know like maybe what the roots are, so we're going to try and solve those now. So 3 things are multiplied to equal 0. So imagine like you've got a times b times c equals 0. If you have any number of terms multiplied and the answer is 0, the zero product property tells us that one of these must equal 0 at a minimum, because the only way to make 0 by multiplication is by multiplying by 0. So 2 cannot be equal to 0, so we can rule that one out straight away. So we would say either x plus 4 must equal 0, so the whole factor is 0, or x minus 5 is equal to 0. In which case x is equal to minus 4 or x is equal to 5. So those would be my two possible x values to get a y value of 0 in terms of my solution. So if I were to graph this at x is minus 4 and x is 5, there's going to be points on this graph. So it would come down, turn, and go back up. Same process for anyone you come across. All right, so you've got 4 of these. Solve them by factoring. Remember, step 1 is to get all of the terms on one side of the equation so that it is equal to 0. Pause the video, try all 4, and then come back and see what the solutions are. All right, so first one, x squared minus 6x minus 5. We got to add 5 to both sides. We got x squared minus 6x plus 5 is equal to 0. Factors of 5 that when you add them together, you get minus 6. That would be minus 1 and minus 5. Remember, to make a positive number, you can multiply 2 negative numbers together. So we get x minus 1 times x minus 5 is equal to 0. So that means my actual solutions are x equals 1 and x equals 5. So you can always check that in Desmos. Throw it in Desmos. See, okay, where does x squared minus 6x intersect with minus 5? Or where does x squared minus 6x plus 5 cross the x-axis? That's another one you can do, and you will get the same answer. So basically, by adding 5 to both sides, we are translating both sides of the equation up 5 units so that x equals 0 or y equals 0 becomes the line that we are looking for, and that's an easier one to solve. So it's easier to solve most equations when one side is equal to 0. Okay, second one, x squared minus 15 equals 1. Subtract 1 from both sides. X squared minus 16 equals 0. Now, do you recognize this situation? This is the difference of 2 squares. So if you have 2 square numbers subtracted, you can call that a minus b times a plus b in terms of factors. So x squared is already squared. 16 is a square number. Remember, 16 is the same as 4 squared. So we would say our factors are x plus 4 and x minus 4. So that means our solutions are negative 4 and positive 4. The difference of 2 squares. If you don't remember that, go check it out on YouTube. So like YouTube it, difference 2 squares, if someone explained it to me, and get that information back in your head. All right, number 3, we've got an a value greater than 1, so we're going to have a little bit more work to do in this one. Let's add 13 to both sides. So we're going to get 4x squared plus 20x. Add 13 to both sides, so we're going to have plus 24 equals 0. Factor out the 4, so everything's going to divide by 4. We're going to have 4 times x squared plus 5x plus 6 equals 0. Factors of 6 that add up to be 5. That would be 2 and 3, or 3 and 2. It doesn't matter. They're both positive. So we would write this in factor form as 4 times x plus 2 times x plus 3 equals 0. And that means 4 can't be equal to 0, so my solutions are x is minus 2 or x is minus 3. Last one. Let's get everything on one side. So I'm just going to add x squared to both sides. I'm going to add 2x, and I'm going to add 24. So plus x squared plus 2x plus 24. So I get minus 2x squared plus 8x plus, so that would be 42 equals 0. I have an a value of minus 2. I'm going to take the minus out as well. It just makes life a little bit easier when you don't have to worry about negative x's and you're trying to factor. So minus 2, and then we got x squared. If I take minus 2 out of 8, I'm going to be left with minus 4. And then minus 2 out of 42, I'm going to be left with minus 21 equals 0. So factors of negative 21 that add up to be -4. That's going to be -7 and +3. So add those together, you get -4. So this is going to be -2 times x minus 7 times x plus 3 equals 0. So -2 can't equal 0, so that means x is equal to +7 or x is equal to -3. So those are my two solutions. So a lot of work in this. Make sure that you are going back, stopping, rewinding if you have any questions about it. Turning up to our afternoon sessions or using the Math Tutoring Center is going to be your best bet. All right, solving by taking square roots. So this one is like a first step. You notice that the quadratic is already in vertex form. So we can tell the vertex is +2 and -20. And then we're asking, well, when is the x value equal to have a y value of 16? So for what value of x is the y value of 16? And it's going to be potentially values. So it's got a positive a value, so that means it's going to open upwards. Vertex at 2, -20. So we know 16 is above that, so it's going to be cutting away up here somewhere. But we know that there's going to be solutions. So that's kind of a nice thing to know, that I know there's going to be solutions even before I start. All right, you're going to solve this like you would using PEMDAS, except remember when we solve, we do backwards PEMDAS. So that's why I have the SAD map up here. So PEMDAS reversed. So we're going to do addition, subtraction first, then multiplication, division, then any exponents and parentheses. So that means subtraction first, 20's got to go. So we get 4x minus 2 squared equals 36. And this is almost exactly what we did in absolute value. Like you were solving down, and then it's just a case of making sure you know how to undo the squaring part. Multiplication next, we're going to divide both sides of the equation by 4. So we're going to get x minus 2 squared equals 9. So now at this point, you can't just add 2 to both sides because there is the square that's happening to both of them. The opposite or the inverse of squaring something is to do the square root of it. So we're going to square root both sides of the equation. So square roots and squares cancel each other out. X minus 2. Now, if you take the square root of 9, there are two possible answers. It can be +3, but it also could be -3, because if you square -3, you get 9. If you square +3, you get 9. So there are two possible answers here. So like absolute value, we are going to split it. X minus 2 is equal to +3. X minus 2 is equal to -3. So the two possible answers. Add 2 to both sides. So we get x is equal to 5 and x is equal to -1. Those are my two solutions here. So the key part is remembering that, like absolute value, when you are undoing squaring, you're going to square root both sides, there's going to be a positive and a negative version of the answer. So just make sure you are accounting for that and not forgetting about it. All right, your turn. We've got 3 different examples here. Solve them down, try and get the value or values of x. So I'll give you a hint, there's none in here that are no solutions. So I'm looking for solutions in this case. It could be 1, it could be 2. Pause the video, come back when you're ready to see the answers. Okay, so first one, there's no solving down to do because it's already the isolated parenthesis with the square on it. So we are going to square root both sides. X minus 5 is left on the left side, and that's equal to plus or minus square root of 81, which is 9. So we add 5 to both sides. So we're going to have x minus 5 is equal to +9. X minus 5 is equal to -9. Add 5 to both sides. X is equal to 14, or x is equal to -4. So there's our two possible solutions. Number 2, kind of what we solved in our example. Subtract 5 from both sides. So we got 2x plus 3 squared is equal to 32. Divide by 2 on both sides. x plus 3 squared is equal to 16. So when we see a square number over here, we're pretty happy because we know this is going to work out nicely. Will not always be the case. Square root both sides. So we're going to get x plus 3 is equal to plus or minus 4. So this is when you split it. X plus 3 is equal to positive 4. X plus 3 is equal to negative 4. And then solve it down. So subtract 3 from both sides. X equals 1 or x equals negative 7. You should still be putting these in Desmos and just checking, is that correct? Do I have the right roots or not? Whole number solutions typically is like a nice thing to happen because it does tell you like you probably have something right going on, but it doesn't always have to be that way. So check your work is the best advice you can get here. Last one. We've got minus 3 on both sides, so we're going to have a half x plus 2 squared is equal to 25. Now to get rid of a half, you're going to multiply by 2 on both sides, or 2 over 1. So the 2 and the 1 cancel, and times 2 over 1 over here. So we're going to get x plus 2 squared is equal to 50. So now we're like, 50 is not a square number, so this is going to be a little bit interesting. Square root both sides. We get x plus 2 is equal to plus or minus whatever the square root of 50 is. Now this is where you need to go dig back into the geometry archive and remember how to simplify square roots. And if that's something you do not know how to do, again, go to YouTube, simplify square roots or simplify radicals, and it will come up for you. So how it works is you take something like the square root of 50 and you ask yourself, what is the biggest square number that is a factor of it? So our square numbers are 1, 4, 9. So you notice that I'm doing 1 squared, 2 squared, 3 squared, 16, 25, 36, 49, and you would just keep going. So like 64, 81, 100, and they just keep on going. What is the biggest square number that is a factor of 50? Well, that would be 25, because we can do 25 times 2 is 50. So you can split a radical into its factors. So that would be root 25 times square root of 2. So root 50 splits into its factors, root 25 and root 2. And the square root of 25 is a whole number. It is 5. So it's going to be 5 times square root of 2. So this is called simplest radical form. So going back to the question we were working on, we're going to say x plus 2 is equal to positive 5 root 2, and x plus 2 is equal to negative 5 root 2. Subtract 2 from both sides. X equals minus 2 plus 5 root 2. So the 5 is being multiplied by the root 2. You can't combine it with the minus 2. Now you could go to decimal form, but if we're being asked to keep things in simplest radical form, this is what it's going to look like for you. And I want you to make sure you're practicing that. Minus 2 minus 5 root 2. So I will ask you to keep things in simplest radical form in our test unless we're solving by graphing. Because at that point, like, you're going to get decimals, so I'm not going to ask you to fix that. So it's 2 solutions. So we've got the minus 2, and then we're subtracting whatever 5 root 2 is. Root 2 is an irrational number, so it's not like you can put in your calculator and then hit math fraction. It'll just stay irrational. So remember, irrational goes on forever with no pattern or repetition going on. Solve by completing the square. This one is going to get us into that vertex form, and then we're going to solve it by taking square roots. So it's going to be a lot of repetition on the last step. We hinted at this in the video lesson for this week, but let's go through it again. For this one, if you're completing the square, we actually just want the x values on one side and we want the numbers on the other side. So a little different to our other steps so far. So that would be x squared plus 6x equals 10. So I added 9 to both sides. For the x squared plus 6, you're going to take the 6, the coefficient of x, and you're going to divide it in half. So you're going to get 3. So it'll be x plus 3 squared is equal to 10. Now I've left this space here because when we do x plus 3 squared, we will get x squared, we'll get that 6x, but we'll also get an extra 9. So doing x plus 3 squared is not the equivalent of x squared plus 6x. So to balance that out, I'm going to have to subtract 9 from it. So that would look like this. So I'd have that plus 9, and then I would take the 9 away again, so that I would be left with the plus 6x and the x squared. So it's just keeping the equation balanced. I'm not changing the value of it anyway. You can add something and subtract it from the same side, and it will not change anything. But if I'm going to subtract 9 from the left-hand side of the equation, I must also do it to the right-hand side. So they are going to have to match. So I will end up with x plus 3 squared is equal to 10 minus 9, 1. Now we're at the point where we solve it. So what we did in our last step. It's already just the x plus 3 squared, so we're going to square root both sides. So we get x plus 3 is equal to plus or minus. Square root of 1 is just 1. So x plus 3 is equal to positive 1. X plus 3 is equal to negative 1. Subtract 3 from both sides. X is negative 2. X is negative 4. So there's two kind of major steps to this. The first is getting it in vertex form, and this is called completing the square. And by square, like we're talking about like the binomial squared. So what you're trying to come up with that number 9. So what is the number you need in order to be able to complete this as a square? So the 9 comes from half of the coefficient of x. So if we're thinking ax squared plus bx plus c, it's going to be half of that b value. And then you square it. So it'll be b over 2 squared, and you're going to have to subtract that from both sides of the equation. So that's where that 9 comes from. All right, here's the second example. This is the one that's going to have two examples because I think this is probably the most complicated of the bunch. So keep the x's on one side, send the numbers over to the other. 2x squared minus 10x equals 13. So now the a value is greater than 1, so we've got a 2 in there at the coefficient of x squared spot. We're going to factor that out. 2 times x squared, 10x divided by 2, minus 5x. So if I distributed that, I would get back to my original starting equation. We're still good. Now we go through the steps from the previous one, half of negative 5. So this one's going to be like as complicated as it gets because it's not going to be nice, pretty whole numbers. So we're going to have 2 still over here times x minus half of 5, 2.5 squared. Now that's going to create an extra number, and we're going to have to subtract it from both sides. So equals 13. So we're going to have to subtract some number from both sides. So we take that 2.5. So 2.5 times 2.5 is 6.25. So we need to subtract 6.25 from this side. Now, this is also a challenging part because technically that 2 is being multiplied by the whole equation. So remember, it was 2 times x squared minus 5x. So we've created a square out of that. The additional number we create is still being multiplied by 2. So that's one that catches so many people out. So really, it would be, if we were to rewrite this, it's 2 times x minus 2.5 squared, and then 2 times minus 6.25 is minus 12.5. So like, yeah, that one is going to catch a lot of people out. You have to be very careful and check your work. So if we're subtracting 12.5 from one side, we got to do it from the other side as well. All right, so that brings us, the plus and the minus are canceling out over here, so we're good. So we're going to have 2 times x minus 2.5 squared is equal to 13 minus 12.5 is 0.5. All right, so we good? Now, solving it. Divide by 2 on both sides. So we're going to have x minus 2.5 squared is equal to 0.5 over 2, which is 0.25. Getting closer. Square root both sides. X minus 2.5 is equal to the square root of 0.25. So square root of 0.25 is 0.5. And we're at plus or minus 0.5. So x is equal to, actually we'll not skip a step, let's keep things as consistent as we can. X minus 2.5 is equal to 0.5. X minus 2.5 is equal to negative 0.5. So x is equal to, add 2.5 to both sides. X is equal to 3, or add 2.5 to both sides, x is equal to 2. And we're done. So yeah, it's like the work in the middle is not the prettiest, but you do end up with nice answers, which is great. And you would always check your work. So you would, even though you're being asked to solve by completing the square, I would still put it in your graphing calculator or in Desmos and see what is my answer supposed to be, and then show my work that gets me to arrive at that answer. So, don't go into it blind and say, oh, I think it's the right answer. Like, actually check it and use one of the other methods to check it. There's nothing against the rules for doing that. If you are asked to solve by using one of the methods, you do need to show the work for that method, however, but you can still check your answer using one of the other methods. All right, so your turn. This one will probably take you a little bit longer. Pause the video. When you're done, come back and see how you did. Okay, welcome back. So first one, subtract 6 from both sides. We're going to have 3 times x minus 4 squared is equal to 75. Divide both sides by 3. X minus 4 squared is equal to 25. Square root both sides. X minus 4 is equal to plus or minus 5. So then, x minus 4 is equal to minus 5. X minus 4 is equal to positive 5. X is equal to minus 1. X is equal to 9. So there's our first solution. Second one, add 2 to both sides. X plus 3 squared is equal to 72. Square root both sides. X plus 3 is equal to plus or minus root 72. Now root 72 can be simplified. Biggest square number factor is 36. So we root 36 times root 2, which is 6 root 2. So we're going to have x plus 3 is equal to plus or minus 6 root 2. Subtract 3 from both sides. X equals minus 3 plus 6 root 2. Other solution, minus 3 minus 6 root 2. So there's our 2 solutions in this case. And then the third one. So let's subtract 11 from both sides. Minus 5 x plus 2 squared is equal to 10. Divide by negative 5 on both sides. X plus 2 squared is equal to minus 2. So now, if you do square root of both sides, square root of a negative number is not possible. So we would say this one has no real solutions or 2 imaginary solutions. And we'll probably come back to this example again in the future to see, like, okay, what would they have looked like if we did do the imaginary solutions? All right, quadratic formula. If you cannot remember the quadratic formula, you should go look up a YouTube video, quadratic formula, and I think it's got the word harmony in it, and listen to that 5 times. You will never forget it again. Those of you who've had me for Algebra 1, I think you might be familiar with it. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So can you rattle it off? Do you know it? In terms of where the letters go, so ax squared plus bx plus c. So we'll have our equation given to us in this form. So there's our a, there's our b, there's our c. They sub into the formula, and this is going to give us two answers because we got that plus or minus part. One thing that you may be asked to check is, does the quadratic have two solutions, one solution, or no real solutions? And you do that using the discriminant, which is the part inside of the square root. So if you think about it, if the square root, what's inside of it is positive, we'll get two answers, the positive and the negative version of it. If it's equal to 0, well, plus or minus 0 is the same number, so there's only one solution, and that'll be a tangent. It'll pass through the vertex. If you're doing square root of a negative number, so b squared minus 4ac is negative, well, that's not possible in the real world, so that means we're going to have two imaginary solutions. So you can check it very quickly. So if I were to do that, b squared, so that's 7 squared minus 4, a value is 8, and c I need to add 6 to both sides because it has to be equal to 0 first. So that would be minus 9. Two negatives are going to multiply together to become a positive. So already I know, like, this is going to be 49 plus 4 times 8 times 9, 288. So I'll get 288, add the two of those together, I get 337. So it's positive, which means we're going to have two solutions. So you may just get asked, that could be a question you get asked, like how many solutions does it have using the discriminant, show using the discriminant. Or how many solutions does it have, how do you know? And you would say, oh, because the discriminant is positive, negative, or equal to 0. So let's go solve this guy. So like I said, you have to add 6 to both sides. It must be equal to 0. So we're going to start with 8x squared plus 7x minus 9 is equal to 0. So it must be equal to 0 before you start quadratic formula. So we got x is equal to minus b, so minus 7, plus or minus square root. And we actually just solved what b squared minus 4ac is, but we'll put it in here for the sec. 7 squared minus 4 times 8 times minus 9, all over 2 times the a value, which is 8. So x equals minus 7 plus or minus square root of 337. So we got square root 337, square root of 337 is not a whole number, so always check it first to see if it is a whole number. So 337 all over 2 times 8 is 16. So then the question would be, is 337 divisible by any square numbers? So remember, square numbers 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 12 squared is 144, 13 squared 169, 14 squared 196, 15 squared 225, and I think I can stop there. Generally where you can stop is you take the number, so 337, divide it by 2, and that's the highest square number that could possibly go into it and have like whole factors. So half of 337 is going to be 150, 160 something. 337 divided by 2 is 168.5. So it was actually really close to being divisible by 169. Oh well. So now we go, all right, 169 does not go into it. So 337 divided by 144, like we know that's not going to work. Just because even numbers, no. So 144, no. 121. So if we did 121 times 2, be 242. 121 times 3 would be 363. So no. 100, definitely not. 81. 337 divided by 81. Nope. 337 divided by 64. No. So let's see, we got no, no. 337 divided by 49. Nope. 337 divided by 25. We know that's not going to work. Oh, I forgot 36. Divide by 36. Nope. So we're left with 16. 337 divided by 16. Nope. 337 divided by 9. No. 337 divided by 4. Nope. So none of the square numbers go in it, which means that this number is in simplest radical form already. So we're done at this point. Our two possible solutions are going to be x is equal to minus 7 plus 337 all over 16, and x is minus 7 minus root 337 all over 16. So yeah, it's not pretty. It's not really tidied up very much, but that's as tidy as we can make it, because minus 7 and 16 are not divisible, and unless I can pull a whole number out of the radical, I can't cancel it down with 16 in any way. So we're done. Those are our two solutions. So we get one solution, two solutions. So if you check that using graphing calculator or something like that, you will get the actual numerical value for like what is minus 7 plus square root of 337 divided by 16, and vice versa with the other way. All right, your turn. Solve using quadratic formula. Pause the video, come back, let's see how you did. All right, so first one, we got our a, b, and c. So x equals minus 3 plus or minus square root b squared, so 3 squared minus 4, a is 9, c is negative 2, all over 2 times 9. One thing to note, because we got minus 4 times minus 2, it's going to be positive. So I know the discriminant is positive. There's going to be two solutions here. All right, so we got minus 3 plus or minus. Let's do what's inside the square root. So we got 3 squared, which is 9. And then 4 times 9 is 36, times 2 is 72. So we're going to have minus 3 plus or minus the square root of 81 all over 18. Square root of 81 is 9, so this is going to actually work out a little bit for us. So we got minus 3 plus 9 all over 18, and minus 3 minus 9 all over 18 are going to be our two solutions. Minus 3 plus 9 is 6. 6 out of 18 is a third. Minus 3 minus 9 is negative 12. Negative 12 out of 18 is minus 2/3. So those are my two solutions, my two values of x. Okay, next one. The 8x squared needs to move over, so this will be 8x squared plus 14x plus 3 equals 0. So a is 8, b is 14, c is 3. So we're going to have x equals minus 14 plus or minus square root 14 squared minus 4 times 8 times 3. So the question here will be, is 14 squared greater than 4 times 8 times 3? So 14 squared is 196. 4 times 8 is 32. 32 times 3. So yeah, it's going to be like 90 something. So we know that we're going to have positive solutions all over 2 times 8. All right, so 14 squared is 196, and 4 times 8 times 3 is 96. So 196 minus 96 is 100. So it's going to be minus 14 plus or minus root 100 all over 16. And root 100 is 10, so this is going to work out nicely for us. So it's going to be minus 14 plus 10 all over 16, and minus 14 minus 10 all over 16. So first one, minus 14 plus 10 is negative 4. Negative 4 out of 16 is negative 1/4. And then minus 14 minus 10 is minus 24 out of 16. So that'll be 6 over 4. Which simplifies to minus 3 over 2. So minus 1.5 and minus 1/4 are our two solutions. All right, last one. It's going to get a little bit messy, but we'll try and make do. 4x squared, add x to both sides, subtract 4 from both sides, we get 0. All right, so x is equal to, b value is 1, so minus 1 plus or minus square root 1 squared minus 4 times minus 4 all over 2 times 4. All right, so 4 times 4 is 16. 16 times 4 is 64. So we're going to have 1 plus 64 because negatives are going to cancel out. So it's going to be minus 1 plus or minus square root of 65 all over 8. Square root of 65, none of our square numbers are going to divide into that. So we can just say, all right, this is going to be x equals minus 1 plus square root 65 all over 8, and x equals minus 1 minus root 65 all over 8. So if you did not get those, once again, get on YouTube, look at solving using quadratic formula, get a couple of examples under your belt, look in the textbook, look in the study packet, so the review packet for Algebra 2, and start solving as many of these as you can and check your work using Desmos or a graphing calculator. All right, that brings us to the end of today. What should I have learned? So, when do I use the different methods? Pretty much you use what you're asked for. If you have the option, if you're asked to find solutions, I like going for graphing and quadratic formula. Graphing because it can be the fastest way there. If you're getting decimals and it just it looks like it could be irrational, quadratic formula would be my next favorite because you're always going to get a solution, so you'll know very quickly if it's real or imaginary, and then you'll get it in radical form as well, so you'll get the whole value solution. After this, you're going to go straight for the math task. So math task that's based on Khan Academy. I think there's 4 or 5 Khan Academies there for you that are going to be based on solving quadratics using different methods. So they're going to go back to the Algebra 1 stuff. We want to make sure we can do that by the end of this unit. If you have questions, after school on Tuesday, Thursday at 12:30, or the study channel, the tutoring session on Monday through Thursday from 5 to 7 p.m. and it's Catoctin Tutoring 1.